we like nice, simple, sensible approaches. And in Aviva, we believe that whether you're talking about an existing facility or you're talking about a new facility, it can result in a digital asset, which of course is the basis for your digital twin. I'm not going to go into a lot of detail right now on this one because, of course, it really does depend on the nature. What I can tell you from experience is that it is possible to digitalize brownfield plants to an extent that you may not think is possible, and it is getting easier and cheaper. And that also includes the behavioral digital twin with the maturity of sensing technology. So I encourage you to reach out to Aviva if you want to know more about that. The execution part of the projects, I'll take a moment to remind everybody, is going to be dealt in a lot more detail by one of my colleagues, Julian De Beer, on May 25th, where he will talk about the actual project execution part in delivering the plant of the future. And he will go into more detail about the steps that we take in a methodology that we at Aviva call EPC 4.0. So I encourage you, if you're really interested in that, to dive into Julian's presentation on May 25th. What I will talk about is why the data-centric execution on the project side is so important for the plan of the future when you get into OpEx. And this is a very key point, because traditionally there has always been a barrier, a wall, a distinction between the project lifecycle and the asset operations lifecycle. It's why we kind of threw in that question in the poll about, well, the digital twin is somebody else's problem. It isn't anymore. And it isn't anymore because we've realized now that we cannot separate these two parts of the life cycle like we used to. So very quickly, what normally happens in a project execution and in handover? We build up information. We build up the information and we try to assure its quality as we go, right? So the y-axis is data quality and completeness. We're supposed to build it up to a point of trust so that when we hand over to the operations side, they know what they have, they can start operating the plant safely, securely, and they can get it up to sort of nameplate capacity as quickly as possible. Well, the reality is that usually there's a shortfall between what we would call trust and where the quality and completeness of information actually is. But even worse, once you get into the operations lifecycle, there is no source of truth. There is no consolidated repository of information that is kept evergreen, that accommodates all the changes, that represents the physical asset as it changes across its operational life. So the quality and completeness of information starts to degrade, and this is for simple reasons as well as complex reasons. A simple reason can be as simple as there are people who keep the important drawings in their desk, and after they've done some work in the field or on the plant, they mark it up and they stick it back in their drawer and they don't share it with anybody. So that is a legacy of kind of siloed information. But this has a real consequence in terms of efficiency. And that is that it is that shortfall of trustworthy data that results in the inefficiencies that we all know about. Crews, maintenance, inspection personnel who spend as much time seeking information and trying to verify it as they do actually turning wrenches and fixing stuff, right? So that's where that gap is. Now, what generally happens is, it gets to a point of panic, somebody spends some money, they do some physical verification, they may as-build some drawings and data and documents, but in the absence of some kind of a integrated, unified set of data that is connected to engineering platforms to keep everything evergreen, you just have the same problem happening over and over again. Now, this can be purposely done in sort of, like I said, verification and re-building efforts, or it can be as part of a turnaround or other sort of asset projects. But the problem is the same. You never really fix the problem working in this way. The plan of the future is done differently. First of all, as I said, it's delivered using this sort of data-centric, what we call EPC or CapEx 4.0 execution on the left-hand side. And my colleague Julian will go into more detail about that later. But the important thing for me today is that the core of information, the digital asset that gets delivered, is the platform on which the living digital twin during the operations lifecycle is built. So from day one, you have an integrated set of information. You have a digital asset that is more than just a digital asset. It is a digital twin that has engineering and asset information now in context. It now has operations and maintenance data also in context, and everything is connected. This is how you can assure that that information is above that level of trust, and you can seek out all of the efficiency gains from having that ready to go. So no need now to send crews to the platform in order to measure up and test equipment before they can produce their work package, before executing a piece of maintenance work. They can do it all sitting at their desk before they go out to the field. So, as I said, the digital asset is the core of the digital twin. It represents the physical asset. It is multifaceted, multidimensional, and multi-interval. What I mean by that is it accommodates information and data across multiple slices of operational life. Milliseconds, seconds, hours, days, months, quarters, years, etc. And we'll get into that. But it also incorporates the structured and unstructured plant data, as well as information coming from systems that, in the case of AVEVA, doesn't necessarily come from our tools. So that's one of the key enablers of our approach. Now, what does this do? And this is kind of another key point for me. I'd like you to kind of step back for a second and just think about yourself as a human being and how you operate. You have this, all of us on this call, have this unbelievable set of capabilities that are built around the way our brain and nervous system actually function. So arguably, we embody the most complex and capable data gathering and processing system that's known. At any given moment, you have essential functions that are running, essential processes. You've got your blood flowing, and you've got your lungs working, and you've got your digestive system working, and your body can do all kinds of clever things. When you eat something, it diverts more blood to your digestive system, right? If you are exerting yourself, it diverts more blood and oxygen to your muscles and things like that, and adrenaline. But what you can also do is operate at a strategic level and at an instantaneous level at the same time. So again, as an example, say you decided you wanted to plan out your career, and you're like, you know what, it's a nice day, I'm gonna go take a walk in the park. Take my shoes off because it's nice to feel the grass under my feet. So you're walking along and you're thinking about, well, you know, maybe I want my next job to be this, and then maybe I want to do some competency development here, and, you know, maybe 5-10 years down the line I can do this, and maybe I want to go work for this company. And you can think strategically. The instant that your foot steps on a thorn or a piece of broken glass, your body takes action within milliseconds. Even before your brain is aware, your muscles have responded, your nervous system has responded, your foot has been lifted out of the danger zone to try to prevent further damage. It has taken a corrective action. And you are then able to pull your attention down to that to see what's happened, to see whether or not there's any damage. Hopefully, what you see is it hurt, but you didn't break the skin, you didn't bleed, you can just carry on. And now you can immediately go back into operations as normal, and you can now start thinking about what you were thinking about before, which is something completely different, and yet very, very relevant to you. Now, I really like that example because for me, it embodies what the plan of the future should operate, or how it should operate. And this is more than just an analogy. It actually is a useful guide for the architectural decisions in terms of digital technologies that the plan of the future needs to be built around. So again, at AVEVA, we believe that unifying data is the key, right? So this is a sort of conceptual view of the layers of architecture that would enable that kind of hybrid intelligent operations where you can be as efficient and as sustainable as possible because you can optimize across multiple dimensions, right? The lower part is your data gathering. It's your sensors. It's the edge. This makes you resilient. This establishes control of your physical assets, like I said, establishes control of your muscles and your skeleton so that your foot can be lifted if you step on a thorn. The higher levels, which are connected at the digital twin, is where you now bring in all that fourth industrial revolution technology and capability, mobility, AR, VR, big data, artificial intelligence, and machine learning. That's what makes you smarter. And for me, it is that approach that will push us towards that kind of human hybrid intelligence sort of performance for the plan of the future. Now, in AVEVA, again, just to show how we look at this, so those technologies that we talked about, so we infuse our life cycles set of solutions, which go all the way from process simulation into value chain optimization with these digital technologies. It's all underpinned by industrial information management and large-scale data collection and processing capability. And then, of course, we have the connection to the data sources. This is where our relationship with OSIsoft, which we have recently acquired, and our big sister company, Schneider Electric, gives us a really unique set of capabilities. So that vision that I just described on the previous slide is something that can be delivered today as a result of the capabilities that we all bring to the table. So just some quick examples, what does that look like? What is, if you're able to sit in front of something that represents a digital twin of the plan of the future, what would that be able to do? And how would that change your life as somebody working in this industry? Well, you would have your engineering information, 1D, 2D, 3D, and more in front of you at all times. You would be able to monitor and control all your real-time processes. And this is, of course, when we talk about efficiency and sustainability and energy management, this is absolutely key. Here, you can actually visualize what energy management means to you and how well you're doing, in addition to seeing the real-time working of all of the processes. And of course, we have actually established that this is entirely possible. So this is a screenshot of perhaps the biggest implementation of something like this that AVEVA has done so far. And this is ADNOC's Panorama, ADNOC being the Abu Dhabi National Oil Company. They have established a massive central digital command center, which they call Panorama, that gives them real-time insight into the operations of 14 of their 16 independent operating companies. So this is a very important point. These are all independent operating companies, all under the ADNOC umbrella, but operating their own systems, operating their own technology. AVEVA was able to unify all of that data, expose it, and bring the power of visualization and collaboration, and then value chain optimization on top of that. By ADNOC's own statement, they believe that this system has unlocked $1 billion for them in the last 3 years. And I encourage you to go and have a look. So what does that example show? It shows that actually the plan of the future is going to turn all of these challenges into opportunities. If you go about it the right way, the key is the data. Whether you're an upstream, where you maybe are looking at trying to remotely operate, or midstream and downstream, where it's all about being agile and responsive, there is solutions based on the approach that I've just showed you that can really enable your ambitions. Another important point is that unification of data provides a platform for artificial intelligence and what you don't know. This comes from a study from AVEVA, sorry, not from AVEVA, from McKinsey, where they looked at the likely impact of artificial intelligence on industrial operators. And the bottom line is, if you are really, by 2030, fully infused with artificial intelligence across your operations, then there's huge benefit on the table for you. Is it going to be exactly 122% impact on cash flow? Who knows? But what it does mean is that it will tell you the things that you don't currently know about yourself, and it will show you where the opportunities are. And that relies on a platform of unified data. Without it, you can't achieve that kind of result. So the final thought was referring back to these quotes from Peter Drucker, right? Yeah, you cannot improve what you cannot measure, and your business might be so complex that it's no longer manageable. Hopefully, we've shown you that there are ways to sit at the meeting place of those two things and actually do what currently think or might not think is possible. But the most important point is that the best way to predict the future is to create it. And what that means is that you need to take the action today and be bold and holistic in your choice of architecture, in your approach to digitalizing, whether it's your brownfield or it's your greenfield. If you want to know where you're going to be in the future, you have to take those steps today. And so that's where AVEVA can help. So I'm not going to spend too much time here. We are the world's largest industrial digitalization software company. With the acquisition of OSI Soft, we now have 20,000 plus customers and 6,500 employees all over the world. And of course, with the backing of our sister company, Schneider Electric, we have unique ability to really bring the power of digitalization to the physical industrial world.